Okay, so today we are continuing proving Pythagorean theorem. Just a note, you're going to continue your notes from yesterday, but you will need your digits book today as well. So we're going to start on page 287 in just a minute. On your notes from yesterday, you might see a right triangle drawn, and you might see that the sides were labeled with numbers or letters. And you might want to remember that the hypotenuse is the longest side of the right triangle, and it is across from the 90-degree angle, most often labeled with the letter C. The two other lengths of a right triangle are labeled with A and B, and they are called the legs. Today, we're going to make the same right triangle, and we're going to make each of the sides into a square. Now, what do I mean by a square? I mean that I'm going to take the side lengths of the side length, we're just going to call this side length 3, this side length 4, and this side length 5, and I'm going to square them. I'm going to basically make a 3 by 3 square here, a 4 by 4 square here, and a 5 by 5 square here. Now, you don't necessarily need to draw this, you just need to picture this or look at your screen right now. We notice something really cool about this when we do this, that if you count up each of these squares, so we have 9 squares here, we have 16 squares here, and we have 25 squares here, and you might already be thinking what's going on here. Yes, if you add them together, this square 9, this square 16, it equals this square 25. And that's true for all right triangles. If you take the two leg lengths and you square them, they're going to equal the square of the hypotenuse length. And this is what is called the Pythagorean theorem. So we have our leg length A, we square it, we get our leg length B, we square it, we add those two together, and we get our hypotenuse length C. We're now going to switch over to your digits book. We're open to page 287, and it has something kind of cool here, another little diagram of the Pythagorean theorem. So we have group 1, and we have our right triangle, and this leg length 6, and this leg length 8. Now, if we actually did square these, this right here would be 36, this right here would be 64, and this right here would be 100, right? I'm just multiplying each of these leg lengths and this hypotenuse by itself. Well, since 36 plus 64 equals 100, it's kind of cool. It's just proving the Pythagorean theorem again. Well, let's look over here. Well, we see our smallest leg length, 5. 5 squared is 25. 12 squared is 144. And 13 squared, our hypotenuse squared, that would be 169. So if we add this 25 and this 144, again, we get this, so 25 plus 144, we get that 169. So here's another visual of how this is proved. What we're going to do with Pythagorean theorem is one of these side lengths will be a mystery, and we will have to solve for it. So if we turn the page, here's just another little a squared plus b squared equals c squared. If we turn the page, we see our first problem. So it says, what is the length of the hypotenuse of a right triangle with the legs of 9 inches and 40 inches? So the first thing I'm going to do, because I am a math teacher, is draw a picture, of course. So I'm going to have, okay, here's my 9 inch, here's my 40 inch, and I'm going to try to find what C is. So using Pythagorean theorem, I'm going to do 9 squared plus 40 squared, and that's going to equal C squared. So again, now we're not really like looking to see if it does equal each other. Now we're actually solving. So we have 81 plus 40 squared. Well, I know 4 squared is 16, so this must be 1600. That equals C squared. I'm going to add 81 plus 1600, and I'm going to get 1681 equals C squared. And now we come to maybe the hardest part of the problem is I have to take the square root of this to get what c equals. For most of us, this step right here is going to require a calculator unless it's something that we've started to memorize. I'm going to assume that a lot of us have not memorized what the square root of 1,681 is, but if you have, great. So anyways, I'm solving for c. So I'm going to take the square root of both sides, and if I typed that into a calculator, I would see that the square root of 1681 is 41, and that is my answer. So that means the side length of c is 41 inches. Okay, and the next problem. Here we go. It says, to the nearest tenth, what is the length of the hypotenuse of the triangle? So again, the hypotenuse is the one that's across from the right angle, so we're solving for c. So I'm going to take what we have. We have our leg length. Usually it goes smallest to biggest, so we have 6 squared plus 11 squared. Now, if you wrote 11 squared plus 6 squared, it is not a big deal. That equals c squared, and we're solving for c. So a lot of this can be done in our head. This is 36 plus 121 equals c squared. We can even do some of this in our head. So this is a 7 and a 5, 157 equals c squared. Now again, this is going to be the step where you need a calculator. I'm going to switch colors. I think I'm going to switch colors. Yep. I'm going to take the square root of both sides. So type it into your calculator. 157 square rooted. Square root of both sides. And I get 12.52 and a really long number. 9964 la 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 equals c. Okay, then I go back up here and I'm like, okay, the nearest tenth. Well, the tenth, remember, is this spot right here. So I know that my c equals 12.5 yards. And that is how you solve for c using Pythagorean Theorem. Your assignment now is to practice this skill. So go ahead and do your next assignment.